Hey guys, my name is David Schuweiler, but most people call me Shu, and in this video I'm going to give you a brief introduction to what you can expect in chemistry this semester. So just a real quick overview of my beliefs as a teacher. I believe that learning is engaging and interactive, constructive, and social. And so we're going to be looking at a lot of different ways in chemistry to support each other and to work together to investigate and explore the world around us using toolkits of science. And so in chemistry, there are 7 themes that we're going to be looking at in the course. And these themes were derived from the Next Generation Science Standards, the North Carolina Standards, and my background as a teacher. So the first of these is the nucleus, and the nucleus is the central part of the atom. That's what contains the protons and the neutrons, and that's where nuclear energy comes from. So the nucleus is what fuels the sun, it's what fuels nuclear decay, and it's how we know how old things are, and there's a lot of energy stored in that nucleus. The second theme is electrons. And so electrons are the thing that orbit the nucleus. And normally when we think about electrons, we think about that planetary model where the electrons orbit the nucleus at fixed distances. That's called the Bohr model, and it turns out that's only part of the story, and electrons are a lot more complicated than that. And in fact, there's a lot of things related to the electrons that scientists disagree about, and we still don't fully understand what the nature of electrons are. But the electrons are responsible for the third theme in chemistry, and that is bonding. So bonding happens when atoms come together to either share or transfer electrons in order to become more stable. And in general, things are more stable when they have less energy, and that has to do with the octet rule, which means that atoms tend to be most stable when they have 8 electrons on the highest energy level available to those electrons in that particular atom. And so bonding then is what drives the fourth theme, which is chemical reactions. And chemical reactions are those processes in which bonding occurs. So in a chemical reaction, bonds are broken, bonds are formed, bonds are rearranged. And as with bonding, chemical reactions are all driven by energy. And so it's all about having as little energy as possible. And energy, coincidentally, is our fifth theme of chemistry. And energy is what drives pretty much all change in the universe. And while energy can be difficult to define, in general, it comes in 2 forms. Kinetic energy, which is the energy of motion. And so in physics, we look at kinetic energy when we look at moving bodies like cars or planets or things like that. But in chemistry, we look at it on a much smaller scale, on the scale of individual atoms and molecules. And so energy is associated with the movement of those particles, of those atoms. And then energy can also come in the form of potential energy, which is the ability to give something kinetic energy to make it move more. And so potential energy is stored in a lot of different forms in chemistry, one of the main forms being in chemical bonds. And it's those chemical bonds that can, when broken, release more energy as they form more stable forms. And so with that, there's also an equilibrium process that happens. And so that's the sixth general theme of chemistry. And in equilibrium, what we're looking at is reversible processes, whether chemical or physical. So a lot of chemical reactions are actually reversible. They happen forwards and backwards. And equilibrium happens when there's a balance between the forward reaction and the reverse reaction. And so that doesn't necessarily mean there's the same amount on each side of that reaction, but it does mean that they're happening at the same rate forward and backwards. Also happens in physical processes. So when we look at water, for example, when water evaporates, a lot of times there's an equilibrium established there between the liquid water and the gas water. And speaking of which, water is our seventh theme of chemistry. Because water, it turns out, even though it's everywhere around us, is a very special molecule. And water has a lot of properties that make it unique and important for us in chemistry. Water is what we use most often to dissolve things. Water is what drives the world around us in terms of energy, in terms of tides, in terms of a lot of different things. And so we'll be looking at water as a special case in which we have things that are dissolved, in which we have acids and bases, and things like that. And so the way that we're going to be using these 7 themes in chemistry is we're going to be using learning progressions. And these learning progressions are basically different ideas that are associated with each of these themes, organized from least complex to most complex. So that means that on one end of a learning progression, there's going to be pretty simple and straightforward ideas. So it's going to be things that doesn't take a lot to really learn. And a lot of you will probably have some of these earlier understandings coming into the course. And those progressions move along towards more complex. And so those more complex ideas are going to be the goal for the course in learning. And the thing is, not everybody starts at the same place in learning progression. So you may be really, really knowledgeable about the nucleus, but know really not much about electrons. Or you may know more about the nucleus than someone sitting next to you, but they may know more about chemical bonding. And so what we're going to do in this course, and the way grading is going to work, is on these progressions, it's going to be all about your growth. So it doesn't matter where you start on the progression, but what does matter is your ability to grow and to learn more along each of these progressions. And so your grade in the course is going to basically be derived from how far along these learning progressions you can move over the course of the semester. So it doesn't matter where you start, it doesn't matter as much where you end up, but it does matter that you're growing. And that's an adapted form of standards-based grading, which basically means that your grade reflects what you know, or in this case, what you've learned, as opposed to whether you turned that homework assignment in on time or whether you were spacing out during a particular test or whatever. And so what that means is we're also going to have a lot of different opportunities to show what you've learned. And so we're going to be looking at a lot of different ways to demonstrate mastery of these ideas and to move you along the progressions. And we'll be tracking your movement along your progress in each of the progressions during each unit. And so during each unit, we're going to be looking at specific phenomena or ideas. And so the idea is that we're going to be anchoring everything we talk about and everything we learn in real-world observations and real-world events. And those are things that we're going to be exploring over the course of the semester in order to understand more about chemistry, understand more about the way the universe works around us, and really more importantly to build our scientific toolkit to be more scientifically literate, to understand what makes good evidence and what claims can we really make from the evidence that's available and how strong are those claims. And so we're going to be asking a ton of questions about these phenomena, and then we're going to be doing investigations through research or hands-on experimentation in order to be able to answer those questions that we have about these events, about these ideas, about these phenomena, and things like that. So with that too, we're going to have a pre-assessment at the beginning, and it's that pre-assessment that we're going to use to demonstrate how far you can move along those learning progressions. And again, it's all about growth. So if you have any questions or concerns at any time, please feel free to contact me, to email me, and I look forward to learning alongside you this semester.